Welcome to this video series and the first video on Level 3 systems of equations. Now, this topic is an extension of a Year 11 algebra concept called simultaneous equations or simultaneous solving. In that topic, we had two things that we didn't know, which we called unknowns, and we represented them with the letters X and Y usually. We also had two pieces of information that we used to solve the problem. Those pieces of information could be written as equations, with X and Y involved, and they could be graphed as straight lines in 2 dimensions. So it might look something like this. If I do a standard graph and I have 2 straight lines like that, for example, we can see that unless those 2 lines are parallel, they must meet at a single point over here. And that point lies on both lines and is a solution to both pieces of information or equations at the same time. So therefore, it solves the problem simultaneously, which is where the name comes from. Now, in this topic, we extend that concept to 3 dimensions. So a line is then extended in 3 dimensions to become a plane, which are these guys up here. A plane is just a rectangle that floats in 3-dimensional space, but it's really the same idea. We also have 3 of them rather than 2. And as you can see in this illustration, we have lots of different ways that 3 planes can intersect with each other depending on the direction and position that they have. In some cases, we might have 3 planes that intersect at a single unique point, or ones that intersect along a line and have infinitely many solutions, or ones that don't intersect at the same place at all and have no solutions. And that's what this topic is about. The last part over here is the general equation of a plane in 3-dimensional space. Hopefully you'll become quite familiar with both of these concepts throughout this series. Let's start by looking at a Year 11 problem, which is a 2x2 system. I say 2x2, and that means 2 unknowns, 2 equations. As I said before, we're going to extend that to a 3x3 system, which, as you can probably guess, is 3 unknowns and 3 equations. The first 2 bullet points in this problem are the 2 equations that I'm going to write. The last bullet point is what I want to actually find out. So we can see I want to find out how many adult tickets and student tickets I should sell. So I can represent those with my variables. X is the number of adult tickets. And so Y will be the number of student tickets. Now I can write those 2 equations in terms of X and Y. So they have 150 seats available. Well, that means that the total number of seats, which is X plus Y, X being the adult seats, Y being the student seats, must equal 150. Our second equation, the total amount of money we make must be $3,600. Now we make money from selling adult tickets and from selling student tickets. So the total amount of money we make from adult tickets is $32 times X, which is the number of adult tickets. Similarly, total student sales is 20 times Y, and that must be $3,600. I can graph those on a grid like this with, along the X-axis we have adult tickets, along the Y we've got student tickets. The first equation, X plus Y equals 150, looks like that. The second one looks like that. Now we can see that those 2 lines meet at a single unique point because the lines aren't parallel, which is this one here, 50, 100. So that means that selling 50 adult tickets and 100 student tickets satisfies both of the requirements of selling 150 tickets and making exactly $3,600. So that solution or that point satisfies both equations simultaneously, and it's the only value that does that. So that's what this whole topic is about. That's a solution to a 2x2 system, but in the remaining videos, we're going to be looking at a 3x3 system with 3 unknowns, 3 equations, with planes in 3-dimensional space. And we'll see all the different types of solutions that we can get. And that's it. Thanks for watching.